Hi, so in this unit, we're going to continue working with trig ratios, right? Sine, cosine, and tangent. Okay, so let's start with some exercise. So my first one is telling me that this person has holding up here a kite forming a 40-degree angle. This is an angle of elevation right here, right? And we want to find the distance, the horizontal distance to where that kite is. So in this case, I have the adjacent and the hypotenuse. So that means that I'm working with cosine. Cosine of 40 equals x over 125. Now I'm just going to multiply times 125 on both sides. So 125 times cosine of 40. That means that x is 95.8 feet. So the next one, I have a building. And from this point, there's an angle of elevation of 30 degrees. So I have the adjacent side and the opposite side. So that means that I'm working with tangent. So tangent of 30 equals x over 300, right? I multiply times 300 on both sides. 300, so times tangent of 30. So that means that x equals 173.2 feet. Okay, so again, this one I have an angle of elevation right here, 25, looking to a airplane, and I want to find that height from that point of view. So that means that here I have, again, I have the opposite and I have the adjacent. So I have the opposite and the adjacent angle or side. So I have tangent of 25 equals x over 75. So again, I'm multiplying times 75 on both sides. So again, x equals 34 or actually 35 yards. Okay. So again, in this case, I have x. This one is 60. This is a right angle. This one is 45. So, and this one I don't have to use 3, right? Because this one is also 45. And as you remember with the 45, 45, 90 triangle, the legs are congruent. So that means that x is 60 feet. Okay. So now I have a person is standing 40 foot from a flagpole. So I have a flagpole over here. I have a person right here. And he's standing 40 foot from that, 40 feet from that one, right? So the angle of elevation is this angle right here. It's creating a 55-degree angle. The person eye level is 4 feet from the ground. So that means that here, this space is 4. And what is the height of the flagpole? So we want to find this height, right? So that means that I have this piece right here is 4, right? So I want to find x, right? So here I have, so here I have 35, I have the adjacent, and I have the opposite. So that means that I'm working again with tangent. So tangent of 35 equals x over 40. So opposite over adjacent. So I'm going to multiply times 40 on both sides. So, so x equals 28, right? So that means that from this point on, this is 28, right? But I want to find the whole height. So from here to the ground. So that means that my height is 28 plus 4. So that means that the flagpole has a height of 32 feet. See? It says you stand 40 feet from a tree. So I have my tree right here, right? And you're standing 40 feet from the tree. The angle of elevation from your eyes to the top of the tree is 47 degrees. Right? So this side right here again is 5. So again I get 47. I'm missing. I want to find this space right here, right? Because I know that from the ground to that top right here is 5 feet. Right? So I have 47. This is the opposite over the adjacent, right? Because this one is also 40. So that means that I have tangent. Again, I have the opposite over the adjacent. So tangent of 47 equals x over 40. Now I'm just going to multiply times 40 on both sides. So x equals 43 feet. So the height of the tree is 43. The next one says an airplane is flying at an altitude of 10,000 feet. The airport at which it is scheduled to land is 50 miles away. Find the average angle at which the airplane must descend. So let me see if I can draw a little plane right here, right? So this is, so I have the airport right here, right? So this town 10,000. So this is 90 degrees. So, and I want to find, so it's 50 miles, right? So that means I want to find this angle, right? Let's call theta, right? So again, I have the adjacent, I have the opposite. So in this case, I'm working with tangent, tangent theta equals, right? But before I write the ratio that goes here, I have to change this to the same unit because right now I have that this one is in feet and 50 is in miles. So I'm going to change 50 miles. So 50 in 1 miles. In 1 mile, there is 5,280 feet. So that means that I have 50 times 5,280. Okay, so I have 10,000 over 264, 264,000, right? So I simplify that fraction. I have tangent of theta equals 5 over 132. I'm simplifying by 2,000. Right? So now, because I'm finding the angle again, so I'm finding the angle. So theta equals the inverse function of tangent. So that is the same as an angle of 2.2 degrees, but it's asking me to round it to the nearest degree, so that means that is 2 degrees. So the average angle that at which the airplane must descend is 2 degrees. So the average angle on which the plane has to descend is 2 degrees. That's it for this one. Okay, so exercise 9 says a cable connects the top of a 20-foot pole to a point in the ground. If the cable forms an angle of depression of 50 degrees, should be instead of down here, it should be degrees. How long is the cable? So let's draw this information. So I have a pole right here, okay, the ground, let's say it's a flagpole, and it's tied with a cable, right? I know that the pole is 20 feet, and it forms an angle of depression, right? So this is the angle of elevation. This is the angle of elevation, and the angle of depression is going to be formed up here. So this is the angle of depression, right? So in this case, these two lines are parallel lines. So this line that I just drew right here and the pole, they are parallel lines. So these two angles are alternate in their angles. So if this angle is 55 degrees, that means that this one is also 55 degrees, right? So I want to find how long is the cable. So that means that right here I have an angle of 55, I have the opposite, and I have the hypotenuse. So that means that I'm using sine. So sine of 55 equals the opposite, 25 over the hypotenuse, right? So I'm going to multiply times x on both sides. So I have x sine of 55 equals 20. And now we're just going to divide by sine of 55. So x equals 24.4 feet. So the cable is 24.4 feet. That's it. See the next. It says a library needs to build an access ramp for wheelchairs. The main entrance to the library is is 8 feet above say walk level. So we have right here. Right, so I have my entrance, and I want to have a ramp right here. Okay. So note that this is 8 feet. The angle of elevation have to be 5, and I want to find out how long must be the access ramp. So how long is this one, right? So again, I have my angle, I have the opposite, and I want to find the hypotenuse. So I have sine of 5 equals 8 over x. Right, so multiplying times x, so x sine of 5 equals 8, and I'm just dividing by sine of 5. So x equals 8 divided by the sine of 5. So it has to be 91.8 feet. So the ramp has to be 91.8 feet. And that's it for this lesson. May the force be with you.